morning and welcome to our next Challenger Connection. I'm Commander Jennifer.
And I'm Sydney.
And Sydney, what are we talking about today?
Rockets.
Rockets, and in particular we're talking about the rocket that will take the next group of astronauts back to the moon. So in 2024, NASA has plans to send the first woman and the next man back to the surface of the moon. And the rocket that they're going to be sending the astronauts on, do you remember what it's called? SLS, the Space Launch System. A huge rocket. And the crew module that the astronauts will be in is called the Orion capsule. Well, the SLS has several parts to it. Obviously, it has the rocket that has all the fuel in it to get them there. It's huge because it has to go about 240,000 miles away to get to the moon. There's the crew module, or the Orion capsule, where the astronauts will be. And then one part of the rocket that you may not have ever thought about. If you see a rocket sitting on the launch pad with the crew on board, there's usually that pointy part at the top, up top above the nose cone. Almost looks like a needle pointing up into the air. Any idea what that is?
The Launch Abort System.
The Launch Abort System, which is obviously a very important part of a rocket. And hopefully it's a part of the rocket that NASA never has to use. The Launch Abort System is designed to safely get the astronauts landed back on the Earth in case of an emergency. So on top of the Orion capsule, you have the Launch Abort System, or the LAS for short. And it has a series of engines on top of it in order to pull the capsule, the crew, away from the rocket. So a couple facts about it that are pretty neat. It can carry the crew to a peak height of around a mile. Pretty far. And it has enough thrust to lift 26 elephants off the ground. So lots of thrust, lots of power. And it can go fast, about 42 times the speed of a drag race car. So obviously, if there's an emergency, you want to get the crew away from the rest of the rocket, not only safely, but quickly. Well, part of the problem when you're lifting something off that quickly, if you don't have it stable, it can get out of control and spin out of control. So it's important that NASA has that LAS balanced. They want to pull the crew away and then land them safely back down on the Earth. So they have to make sure they get it balanced so that the crew's not spinning wildly out of control. So they have to find something called the center of gravity. Any idea what that is? What does it make you think of?
Us balancing.
Balancing, right? So think about if you've ever stood on one foot and you're trying to stand there and you're kind of wobbling. What do you do to help balance yourself?
Put your arms out.
Maybe put your arms out to try to spread out some of that weight or mass, right? So when you're finding the center of gravity on something, you're finding the point where you have the mass spread out equally so that it'll balance, basically. So that's what NASA had to do. So they have something on some of their launch abort systems called a ballast. Ballast is usually some type of piece of metal, like a ball, something like that, in order to add mass to different parts of the LAS in order to get it to balance correctly. So what we are going to do for our activity today is we're going to build our own LAS, and we're going to try to get it balanced. We're going to try to find that center of gravity to get it to balance. So the materials that you'll need for this, you will need a popsicle stick. It really doesn't matter what size. They can be the bigger ones, the smaller ones. And luckily Sydney volunteered to eat the popsicles, so we would have a couple of popsicle sticks. So we've got those. You're going to need a pipe cleaner. And then you are only allowed 4 paper clips. So you'll need 4 paper clips. These will act as the ballast, or the things to try to equalize some of that mass. All right? So we're getting our materials out here. There's Sydney's 4. so let's show you what to do. All right, so we've gathered our materials. We each have a popsicle stick. We have our pipe cleaner, and then we have our 4 paper clips. So I'm gonna put my paper clips out of the way for a minute. And what we're gonna do is we're gonna take our pipe cleaner and we're gonna lay it flat in front of us just like that. You're gonna take your popsicle stick and lay it on top of your pipe cleaner so that you have just a little bit of it hanging down. And then we're gonna wrap our pipe cleaner, this little leg of our pipe cleaner to that side, and that one over there, basically wrapping it around. And we're gonna turn it over and do the same thing. So now you've got your pipe cleaner wrapped around your popsicle stick. Now we need to make our pipe cleaner into a loop. So we're gonna curve it around on both sides and twist those 2 ends together to make a circle, to make a loop. Oops, mine came apart. Twist it again. Alright, so once you have yours all constructed, it should look like this. You should have your popsicle stick here, and then you should have your pipe cleaner in a loop down near the bottom. So our goal is to try to get this to balance on our finger. Do you think that's going to be very easy to do? So we want to hold out our finger. We're going to sit our popsicle stick on our finger to see if it can balance. What do you think is going to happen when we let this go, Sydney? Do you think it's going to balance? What do you think it's going to do?
Fall.
I think it's going to fall. All right, well, we'll see. So when we let this go, we want to see if it'll balance. So let's see. Oh, definitely not. So why do you think that happened?
It's too heavy on top.
Too heavy on top. We've got too much mass up here on the top of our Launch Abort system, which happens a lot, especially if they have the engines on top, which the Orion capsule, its Launch Abort system, will have engines on top. So some of the mass, a lot of the mass will be on the top. So what we have to do is we have to try to counteract some of that mass, which means we want to get it equalized on here. We don't want all the mass just to be at the top. We're going to have to add some mass on the bottom, right? So that's where our paper clips are going to come in. These are going to be the ballasts, or the things that NASA uses to help try to distribute some of that mass. So what you'll do is you'll take your paper clips, remember you can only use 4, and you're going to place them on your pipe cleaner where you think they should go in order to help equalize some of that mass, distribute some of that mass. So Sydney, go ahead and put yours on there where you think they need to go. And they can go anywhere on here you think they should. If they all need to go on one side, if they need to all go on the bottom, if they all need to spread out, whichever way you think they need to go to help distribute some of that mass. Now this Launch Abort system usually weighs about 16,000 pounds. So they don't want to have to add a ton of mass or weight, because remember, the more weight that they add, the more thrust they're going to have with the actual rocket to get it to lift off the ground. So that's another thing they have to think about. Not only do they want it to be balanced, but they don't want to have to add so much extra weight that they're adding a lot of extra weight to their rocket. All right, so we ready to try it out again?
Mm-hmm.
Ooh, a little bit better. Not quite. So, that is your challenge. You're going to add your ballast to your Launch Abort system until you can get it to balance on your finger. Try to find that center of gravity. And you don't want to use your finger or your hand as a crutch like mine kind of just did. You know, oh yeah, it's kind of staying up. Really, it's not. It's hitting my finger right there. We want it to be balanced on our finger. So you may have to move these ballasts, adjust them, test it out as many times as you need to until you can get it to balance. Put some videos or pictures in our comments so we can see how you were able to construct or engineer your launch abort system. I'm Commander Jennifer.
And I'm Sydney.
Over and out.